Hello guys, I'm Shashwardhan. I'm a payment of artificial neural network. Today I'm going to explain about the associative memory and bidirectional associative memory. Coming to the associative memory is defined as the ability to learn and remember the relationship between unrelated items. For example, remembering the name of someone or the aroma of a particular perfume. From this example, we know that the two examples are unrelated. So, by defining this, we can define associate memory. And associate memory deals specifically with the help of relationship between different objects or concepts. A normal associative memory task involves testing particles on their recalls of particular unrelated items. And associative memories, the retrieved memory and its query are typically represented by binary form or in bipolar form, or real vectors describing patterns of neural activity. And yeah, coming to the pattern association, learning is the process of forming associations between related patterns. Each association is an input-output vector, contains an input-output vector. These patterns were associated together, maybe same type of or different types. If each vector t is same and the vector with which is associated, then the net is called associative, auto-associative memory. If t's are different from the s, then the net is called heteroassociative memory. In each of the cases, the net not only learns the specific pattern pairs that we use for training, but also it able to recall the desired pattern, response pattern, which given an input stimulations that is similar but not identical to the input. Coming to the training algorithm for pattern association, similar to Hebbian learning for classification, algorithm for bipolar or bipolar patterns. For each training samples, increase in both SI and TJ. Instead of obtaining W by iterative updates, it can be computed from the training set by calculating the output product of SNT. And these are the outer product S and TB row vectors. Then for particular training pair, it involves three nested loops Pij, three nested loops for to obtain the training pair. So coming to the delta rule, in its original form, the delta rule assumed that the activation function for the output unit was the identity function. A simple extension allows for the use of differential activation function. We shall call this extended delta rule. Next, coming to the heteroassociative memory. Associative memory neural networks are the nets in which the weights are determined in such a way that the net can store a set of p pattern associations. Each association is a pair of vectors s of p comma t of p with p equal to 1 comma 2. So each vector is an n tuple, has n components, and each is as m tuple. The weights may be found using the Hebb rule or the delta rule. This is the diagram for heteroassociative memory. Coming to the example of heteroassociative memory, binary pattern pairs, total weight inputs to output units, and activation function threshold. Weights are computed by Hebbian rule, products of all sum of outer products of all training pairs. Training samples. Here below the example is given as training samples. Yeah. Next, coming to the same heteroassociative memory example as I explained before, computing the weights based upon the given inputs. And same example. Coming to the auto-associative memory, for an auto-associative net, the training input and target output vectors are same, identical. The process of training is often called storing the vectors, which may be binary or bipolar. The performance of the net is judged by its ability to reproduce a stored pattern from noisy input. Performance is in general better for bipolar vectors than for binary vectors. Compared to the binary vectors, the performance for the bipolar vectors are good compared to the binary vectors. Next, coming to the auto-associative memory. Sorry, same as heteroassociative nets, except t of p equal to s of p. Use it to recall a pattern by its noise or incomplete version. A single pattern is stored weight computed by Hebbian rule, as we discussed in the above. And this is the training part, this is noisy part, missing information, and more noisy part. Yeah, coming to the auto-associative memory, the preceding process of using the net can be written more succinctly as the given numerical form. As before, the differences take one of the two forms: mistakes in the data or missing data. The only mistakes we consider are changing from +1 to -1 or vice versa. We use the term missing data to refer to a component that has the value 0 rather than either +1 or -1. Iterative auto-associative memory. In some cases, the net does not respond immediately to an input signal with a stored target pattern, but the responses may be enough like a stored pattern. Testing a recurrent auto-associative net stored vector with second, third, and fourth components set to 0. The weight matrix to store the vector is given as like this, and yeah. Iterative auto association memory. This is a basic example. Next, as we completed our first part, associative memory, and coming to the second part, bidirectional associative memory, also shortly known as BAM, first proposed by Bart Kosko, and heteroassociative network. It associates patterns from one set A to pattern from another set B, and vice versa. So generalize and also produce correct outputs despite corrupted or incomplete inputs. It will produce an accurate outputs with respect of given inputs, and consists of two fully interconnected layers of processing elements. There can also be a feedback link connecting each node itself. Bidirectional associative memory BAM. The BAM mapping of an n-dimensional input vector xn into the m-dimensional output vector. A BAM network, each node may also be continued to itself. Bidirectional associative. How does BAM work? This is the working function of BAM. Here is the fun function is there. One with 1 2 JM with many different bidirectional. Similarly, that one is also that J also connected with the one. It is in bidirectional form. This is input layer and this is the output layer. And the input vector is applied to the transpose of weight matrix to produce an outer vector. Then the outer vector is applied to weighted matrix to produce a new input vector. This process is repeated until input and output vectors become unchanged. Basic idea behind the bidirectional associative memory is store pattern pairs. It stores the pattern pairs so that when n-dimensional vector x from a set A is presented as input, the BAM recalls m-dimensional vector y from set B. But when y is presented as input, the BAM recalls x. Bidirectional associative memory BAM. Step 1, storage. The BAM is required to store a m pair of patterns. For example, we may wish to store 4 pairs. Here is given x2, x3, x4, y2, y3, y4, x1, x2, x3, x4, y1, y2, y3, y4. In this case, BAM input layer must have 6 neurons and output layer has should have 3 neurons. Next, the weight matrix is determined as W equals to xm into y to the power t or base m. It is similarly written in the numerical form. And coming to the step 2 in bidirectional associate memory, the BAM should be able to receive any vector from set A and retrieve the associated vector from set B, and receive any vector from set B and retrieve the associated vector from set A. Thus, the first we need to confirm that BAM is able to recall ym when presented with xm. That is given equation ym equals to sign. For instance, y1 equals to sine of w power t, x1 equals to sign of this is the function that we going to perform in this step 2 training function. And coming to the bidirectional associative memory BAM, then we confirm that BAM recalls xm when presented with the ym, that is the function xm equals to sine of w into y. Yeah. Coming to the step 3 in bidirectional associative memory, it present an unknown vector x to the BAM to retrieve and retrieve a stored association. Association. The probe may be present as a corrupt or incorrupt version of a pattern from set A or from set B. or from set B stored in the BAM. That is first step is initialize the BAM retrieval algorithm by setting x of 0 equals to x and p equals to 0, and we need to calculate the BAM output an iteration p. And next we need to update the input vector x of p. Next, repeat the iteration until we need to repeat the iteration until equilibrium, when input and output vectors remain unchanged with the further iterations. So the input and output patterns will then represent an associated pair. The BAM is unconditionally stable. This means that any set of associations can be learned without risk of instability. This is important quality arises from the BAM using the transpose relationship between weight matrices in forward and backward directions. Let us now return to our example. Support vector, we use vector x as a probe. It represents a single error compared with the pattern x1 from set A. This probe applied as a BAM input produces the output vector y1 from set B. This vector y1 is then used as an input to retrieve the vector x1 from the set A. Thus the BAM is indeed capable of error correction. So I have just explained the basic things that are what going under the associative memory and bidirectional associative memory. What is associative memory and what is pattern association, and also a training algorithm for pattern association and outer product, and the delta rule, and heteroassociative memory, and heteroassociative memory, example of heteroassociative memory, and finally then we came to the bidirectional associative memory. In bidirectional associative memory, we have learned about example for bidirectional associative memory and how it works, and how bidirectional functionality will works, and also some examples, and steps that are included in the bidirectional associative memory. Total 3 steps: retrieval, and first step, third step is retrieval, and second step is testing, and first step is storage. Thank you guys.